SwayamPrabha. Digital India. Educated India.
Sustainable and green chemistry approach for treatment of textile effluent. Lecture number 11. In this, we will try to understand what are the green chemistry approaches which have been devised for the treatment of textile effluent, so that the process becomes sustainable. Treating textile effluent using sustainable and green chemistry approaches is crucial for mitigating environmental impact while ensuring the textile industry's sustainability. Here is a step-by-step approach. Source control and reduction. In the previous lecture also, we were talking about source control and reduction. Minimize the generation of effluent by implementing practices such as process optimization, water recycling and efficient dyeing techniques. This reduces the volume of effluent needing treatment. So, at source itself, we need to cut down any kind of excess use of chemical or water, and that is particularly so because if we have less of effluent, we have less of problem to solve the mitigation problem of the textile effluent. Biodegradable chemicals. Replace conventional chemicals with biodegradable alternatives. For instance, use natural dyes instead of synthetic ones and employ enzymes for processes like desizing and scouring, which are biodegradable. Adsorption technique. Utilize natural adsorbents like activated carbon, zeolite or agricultural waste such as rice husk or coconut shell to remove colorants, heavy metals and other pollutants from the effluent. Membrane filtration. Employ membrane technologies like ultrafiltration, nanofiltration or reverse osmosis to remove suspended solids, dyes and salts from the wastewater. These processes consume less energy compared to traditional methods. Advanced oxidation processes, AOPS, we had studied that in the last lecture. Implement AOS like photocatalysis using titanium dioxide or zinc oxide or ozonation to degrade organic pollutants in the effluent. These methods produce fewer harmful byproducts compared to conventional oxidation techniques. So, in order to make a sustainable process using green chemistry approach for the treatment of textile effluent, we need to adapt safer modes of mitigation rather than conventional modes. Biological treatment. Utilize biological treatment methods such as activated sludge, biofilters or constructed wetlands to degrade organic compounds in the effluent. Microorganisms break down pollutants into harmless byproducts like water and carbon dioxide. Closed loop systems. Implement closed loop water system where effluent is treated and recycled back into the production process. This reduces freshwater consumption and minimizes effluent discharge. So, wherever it is possible, the recycling of the water should be encouraged by closed loop system. That way there will be less of textile effluent generated in the first place. Life cycle assessment. In the last lecture we had discussed about life cycle assessment. Conduct LCA to evaluate the environmental impact of different treatment approaches and identify areas for improvement throughout the textile production life cycle. So, if we carry out LCA, we make sure that we are not enhancing any kind of environmental load, and by doing the LCA, different treatment approaches can be identified and improved in the textile production cycle. Green solvents and surfactants. Replace toxic solvents and surfactants with eco-friendly alternative such as supercritical carbon dioxide or bio-based surfactants. So, wherever possible, if we can replace the hazardous chemical with bio based chemicals, then because they are biodegradable, they are falling into the category of green chemistry approach. Continuous improvement and innovation. Invest in research and development to continually improve treatment processes and develop innovative solutions that further minimize environmental impact. By adopting these sustainable and green chemistry approaches, the textile industry can significantly reduce its environmental footprint while ensuring compliance with regulations and meeting consumer demand for eco-friendly products. So, continuously there is a need for doing innovation. How best we can make the textile processing method safe and more green, more biodegradable effluent will be generated, so that the effluent treatment does not become a tough job. Benefits of practicing sustainable and green chemistry approach. Why should we at all do green chemistry? What are the benefits and how does it relate to sustainability is what we will learn in this lecture. Implementing sustainable and green chemistry practices for treating textile effluent offers several benefits. One of course is the environmental protection. Traditional textile effluent treatments often involve harsh chemicals that can harm aquatic ecosystem when discharged into water bodies. Green chemistry approaches prioritize using environmentally friendly chemicals and processes, reducing the ecological impact of effluent treatment. So, first and the foremost concern is the environmental protection, and that is a big benefit, because in today's time the processes that are still being practiced are quite dangerous and are exuding textile effluents which are full of hazardous pollutants. Resource conservation. Sustainable chemistry aims to minimize resource consumption and waste generation. So, how can we use the same resource? Thereby we will be able to control the waste generation. By employing efficient processes and recycling strategies, it conserves water, energy and raw materials, thereby reducing the overall environmental footprint of the textile production. So, if we look in totality, we will see that if we use the resources that are generated or the byproduct, then there will be less waste generation, and that is a very good situation. Health and safety. Green chemistry emphasizes the use of safer chemicals and processes, minimizing the risk of exposure to hazardous substances for workers in textile factories and surrounding communities. This approach or this promotes a healthier work environment and reduces the potential for adverse health effects. So, it is a very safe mode in which these chemicals will be used, and they will be taken into account that they do not affect the safety of the environment and they do not affect the health of the human being in and around these factories. Cost saving. While initial investment may be required to adopt sustainable technologies, in the long run they can lead to significant cost saving. For example, using less water and energy reduces utility bills, and implementing recycling measures decreases waste disposal cost. So, somewhere or the other we need to weigh and see how cost cutting can be done. If the resources can be reused, there also there is a saving, and if the byproducts can be reused, that is saving. And if by doing this recycling we are using some energy, then that energy cost can be compensated by the resource cost. Regulatory compliance. Many countries have strict regulations governing the discharge of textile effluent into water bodies. By adopting sustainable and green chemistry practices, textile manufacturers can ensure compliance with environmental laws and avoid costly fines and legal issues. So, even regulatory compliance can be made easily if we are looking into sustainable and green chemistry approach, because there will be less amount of hazardous chemicals and less of such mitigation would be required. Consumer demand. As awareness of environmental issues grows, consumers are increasingly seeking products that are produced sustainably and responsibly. You will see that many of these brands, they advertise that they are making it in a very sustainable manner. Levi's, they make jeans, Fab India, they make lot of garments, they all publicize that. So, it is the consumer's demand. Even the consumer is now aware that anything which has been made by a sustainable process seems to be safe for them as well as for the environment. Innovation and collaboration. Embracing sustainable chemistry encourages innovation and collaboration among researchers, manufacturers and policy makers. This collaboration can lead to the development of new technologies and processes that further improve sustainability of textile production and effluent treatment. So, continuously innovation has to be done. We cannot say that this is it, that now research has ceased, now no more research will be done, this is the full and final research that has been. Continuously more research is being done and should be done to find safer, sustainable, green approach for textile effluent treatment. Long term viability. Sustainable and green chemistry practices ensure the long term viability of textile industry by reducing its environmental impact and resource dependency. By investing in sustainable solutions today, textile companies can secure their future operation amidst growing environmental concerns and regulatory pressures. So, in long term also, this approach is going to be beneficial. It is not just for today that we practice sustainable practices and look at the green chemistry approach and feel happy. It is a long drawn process. Every day we have to become greener and greener and replace as many hazardous chemicals that are being used in textile processing, so that the textile effluent that is generated is safe. Implementing source control and reduction strategies is essential for achieving a better and more sustainable approach to managing textile effluents. Here is how source control and reduction can be beneficial. See, if we control the source which is actually causing pollutants, how if we can reduce it, we can optimize it, we can make it optimal, that itself will be a big help in reducing the load in the textile effluent of organic pollutants. Prevention of pollution. Source control focuses on preventing pollution at its origin by addressing the root causes of effluent generation. By implementing measures such as process optimization, cleaner production techniques and the use of eco-friendly chemicals, textile manufacturers can minimize the generation of hazardous pollutants in their effluent. So, prevention is better than cure. If we can prevent, you must have heard this proverb, prevention is better than cure. So, if we prevent or if we can prevent using chemicals which are going to be eventually hazardous material in the textile effluent, it is the best that we can do in order to control the pollution levels of textile effluent. Efficiency improvement. Source reduction often goes hand in hand with process optimization, leading to increased efficiency in textile production. By reducing the consumption of water, energy and raw material, manufacturers can lower production cost and improve their overall competitiveness. So, if we try to optimize the use of energy, water and hazardous chemicals which are mandatory to be used, then definitely it is very beneficial for the manufacturer. Minimization of treatment cost. Treating textile effluent can be expensive, and we have seen that some of these methods are very cost intensive, especially when they contain high concentrations of pollutants. By reducing the volume and pollutant load of effluents at the source, textile companies can lower their treatment costs and alleviate the burden of wastewater treatment facilities. So, if we minimize the chemicals, if we optimize the processes by using optimal amount of water, energy and raw material, then definitely there is cost cutting. Compliance with regulation. Source control measures help textile manufacturers comply with the environmental regulations by minimizing the discharge of harmful pollutants into water bodies. By proactively managing their effluent stream, companies can avoid fines, penalties associated with non-compliance and maintain a good standing with regulatory authorities. Protection of ecosystem. Textile effluent can contain a variety of pollutants including heavy metals, dyes and toxic chemicals, and this we have seen and learned from lecture number 1. Even in the lecture number 11 we are talking about how to protect the environment from all these toxic chemicals which remain in the textile effluent after the wet processing of the textile, and then they are discharged into the aquatic system. If they are not treated and if they are untreated and run into the aquatic system, the ecosystem of the aquatic life will surely get disturbed and will get destroyed even. Source control measures help prevent these pollutants from entering water bodies, thereby protecting aquatic life and preserving biodiversity. Enhance corporate image. Adopting source control and reduction strategies demonstrate a commitment to environment stewardship and sustainability, which can enhance a company's corporate image and reputation. Consumers, investors and other stakeholders are increasingly concerned about the environmental issues and are more likely to support companies that take proactive steps to minimize their environmental footprint. Now, many of these companies are publicizing that we are following sustainable measures, we are following the ZDHC, that is zero discharge hazardous chemical phenomena and all of that. It shows a good image about that corporate house. Encouragement of innovation. Source control and reduction initiative drive innovation in textile production processes and technologies, because it is not just one time research. Research is a continuous process and it must go on. Every time we do research, there is always a scope to do something better in future, and that is how it should go on. New technologies have to be brought in which are even safer than the previous ones. By challenging conventional practices and seeking alternative solution, companies can discover new ways to improve efficiency, reduce waste and minimize environmental impact. So, these are the 3 criteria on which the innovation should be based. Either it should reduce the waste, or it should be very efficient process, or and finally and more importantly, it should reduce the environmental impact. Long term sustainability. Ultimately, source control and reduction are essential components of long term sustainable approach to managing textile effluents. By focusing on prevention rather than treatment, companies can create a more resilient and environmentally responsible business model that benefit both the industry as well as the planet. Using biodegradable chemicals is a cornerstone of a sustainable approach to managing textile effluent. Here is why we should do so, because If we are replacing the hazardous chemicals, non-biodegradable chemicals by biodegradable chemicals, we are at least moving towards sustainable approach. Environmental compatibility. Biodegradable chemicals break down into harmless substances through natural processes, reducing the environmental impact of textile effluent discharge. Unlike conventional chemicals that persist in the environment and can accumulate in the ecosystems, biodegradable alternatives minimize pollution and support ecological balance. Reduce toxicity. Biodegradable chemicals are typically less toxic than their non-biodegradable counterparts. By using these safer alternatives in textile processing, manufacturers can minimize the risk of harm to aquatic organisms, wildlife and human who may come in contact with effluent contaminated water. So, if we reduce the toxicity, we have many benefits. We are saving the lives of wildlife, aquatic organism and human being and all the flora and fauna around us. Therefore, biological treatment compatibility must be looked into. Textile effluents often undergo biological treatment process such as activated sludge or bioremediation to remove pollutants from discharge. Biodegradable chemicals are more compatible with these treatment methods as they can be broken down by microorganisms easily into simpler non-toxic compounds, facilitating more effective and efficient treatment system. Resource conservation. Biodegradable chemicals are often derived from renewable resources such as plant-based materials, reducing reliance on finite fossil fuel reserves. Additionally, their use contributes to resource conservation by minimizing the consumption of water and energy in effluent treatment processes. So, how much can we conserve our reserves, the reserves of water, the reserves of energy, because as you know, the fossil fuel is getting depleted and right now we are dependent mostly on the fossil fuel for energy. So, if we lower the consumption of the reserves, we are in a better position. Regulatory compliance. Many environmental regulations restrict the discharge of toxic pollutants into water bodies, including those commonly found in textile effluents. By using biodegradable chemicals, textile manufacturers can ensure compliance with these regulations and avoid fines or legal penalties associated with non-compliance. So, you see, even when it comes to regulatory compliance, if we are using sustainable and green chemistry approach, definitely we are working within the compliance limit and we are following the norms laid down by the regulatory bodies. Consumer demand. As consumers become increasingly concerned about the environmental sustainability, these are growing demand of products that are manufactured using eco-friendly processes and materials. Textile companies that use biodegradable chemicals demonstrate their commitment to sustainability and may attract environmentally conscious consumer who prefer greener alternatives. So, there is a large awareness of turning into green. Everything which is safe or towards safety is welcomed even by the consumer. Today's consumer is very aware about the sustainability factor and the green chemistry approach. Innovation and development. So, continuously by adopting biodegradable chemicals in textile production, it derives innovation and development in the chemical industry. Manufacturers are continuously researching and developing new biodegradable formulation that offer improved performance, cost effectiveness and environmental sustainability. Further advancing the transition towards greener textile processing. Long-term viability. Incorporating biodegradable chemicals into textile processing promotes long-term viability of the industry by reducing its environmental footprint and enhancing its resilience to regulatory and market pressures. By embracing sustainable practices, textile companies can future-proof their operation and maintain a competitive edge in an increasingly eco-conscious marketplace. So, today everybody is looking for eco-friendly textile, which encompasses textiles that have been made by sustainable and green chemistry approach, thereby saying that they use mostly biodegradable chemicals. Adsorption techniques play a crucial role in the sustainable treatment of textile effluent. To show how they are beneficial, here are some points. Removal of color and dyes. Textile effluent often contains various dyes and colors, and we have seen this from lecture number 1, we are learning about this, which can be challenging to treat using conventional methods. Adsorption techniques such as activated carbon adsorption or dye specific adsorbents effectively remove color and dye from the effluent streams, leading to cleaner water discharge. Reduction of chemical oxygen demands, that is COD. Textile effluents typically have high COD levels due to the presence of organic compounds from dyes, sizing agents and other processing chemicals and auxiliaries. Adsorption processes can significantly reduce COD by adsorbing organic pollutants onto adsorbent surface, improving the biodegradability of the effluent for subsequent biological treatment. So, adsorption technique can also remove heavy metals. Some textile dyes and auxiliaries contain heavy metals such as chromium, lead and cadmium, which are harmful to the environment and human health. The adsorption techniques, particularly using specific adsorbent like chelating resins or modified clays, selectively capture heavy metals from effluent stream, preventing their discharge into the water bodies. Versatility and adaptability. Adsorption techniques can be tailored to target specific pollutants present in textile effluent. Depending on the composition of the effluent and the pollutants of concern, different adsorbents and operating conditions can be employed to achieve optimal removal efficiency. This versatility makes adsorption a flexible and adaptable solution for effluent treatment. So, because adsorption is very adaptable and versatile, it can be used at any stage of the textile effluent treatment process. Reuse and resource recovery. Time and again we have been talking about reuse and resource recovery, because if we remove the reusable part from the sludge or from the effluent, then definitely the volumes of the effluent or sludge will go down, disposal costs will go down, treatment costs will go down, and so on. Adsorption process can facilitate the recovery and reuse of valuable materials from textile effluents. For example, activated carbon adsorption can concentrate dyes and other chemicals, allowing for their recovery and potential reuse in textile production processes, thereby promoting resource conservation and circular economy principle. And this word we had learned a couple of lectures back. Energy efficiency. Compared to some conventional treatment methods such as chemical precipitation or membrane filtration, adsorption technique typically requires lower energy inputs, making them more energy efficient and environmentally friendly. This is particularly beneficial for reducing the overall carbon footprint of textile effluent treatment processes. Cost effectiveness. Adsorption technologies often offer cost effective solutions for textile effluent treatment, especially when considering their effectiveness in removing multiple pollutants simultaneously. While the initial investment in adsorbent and equipment may be required, the long term operational costs are generally lower compared to the other treatment options. So, they are by and large adsorption is cost effective. Regulatory compliance. Many environmental regulations mandate strict limits on pollutants concentration in industrial effluent, including those from textile manufacturing. Adsorption techniques can help textile companies meet regulatory requirements by effectively reducing pollutant levels in their effluent discharge, ensuring compliance with legal standards and avoid potential fines or penalties. So, you see that these are very safe methods even from the regulatory point of view. Overall, we can say that adsorption techniques represent a sustainable and efficient approach to treating textile effluent, offering numerous benefits in terms of pollutants removal, resource recovery, energy efficiency, and regulatory compliance. So, overall adsorption is one technique which is very much welcomed in the effluent treatment while discussing sustainable and green chemistry approach. Then comes membrane filtration. Even membrane filtration is considered to be sustainable approach. Membrane filtration is indeed a sustainable approach for treating textile effluents, offering several advantages. Pollutant removal. Membrane filtration effectively removes a wide range of pollutants from textile effluents, including suspended solids, dyes, organic compounds, and microorganisms. This leads to cleaner discharge water, reducing the environmental impact on receiving water bodies. Water reuse and recycling. Membrane filtration enables the recovery and reuse of treated water from textile effluents, promoting water conservation and reducing the demand for freshwater resources. Treated water can be recycled for various purposes within the textile manufacturing process, such as dyeing, washing or cooling, thus minimizing the need for fresh water intake and wastewater discharge. So, another very important aspect is that can we recycle the water? If it is less polluted and by merely decolorizing it, we can use it for dye bath or for cooling purposes, then that is a very good situation in terms of sustainable approach. Selective separation. Membrane filtration offers selective separation based on the size and molecular weight of pollutants, allowing for precise control over the effluent quality. Different membrane types such as microfiltration, ultrafiltration, nanofiltration and reverse osmosis can be employed depending on the specific treatment objectives and the characteristics of effluent. Energy efficiency. While membrane filtration requires energy for operation, it is often more energy efficient compared to conventional treatment methods such as chemical precipitation or thermal evaporation. Advances in membrane technology, including membrane material and module design, have led to improvements in energy efficiency and reduced operational cost over time. So, these membranes have also been found to be very energy efficient. Over a period of time, designs and models of the membrane filters are made so that they use less and less amount of energy. Compact footprints. Membrane filtration systems typically have a smaller footprint compared to conventional treatment processes, making them suitable for installations where space is limited. This compact design allows for decentralized treatment solution, bringing the treatment closer to the point of effluent generation and minimizing the need for long distance transportation of wastewater. So, now compact models of filtrations have been made which can be kept at the site. So, there is no need to transport the effluent to a larger distance for its purification or mitigation. Reduce chemical usage. Membrane filters can reduce the reliance on chemical additives for effluent treatment, as it primarily relies on physical separation mechanisms, and this minimizing the generation of chemical sludge. So, this minimizes the generation of chemical sludge and use of potentially hazardous chemicals, contributing to a safer working environment and reducing the environmental impact of chemical discharge. Regulatory compliance. Membrane filters from the regulatory compliance point of view also help textile manufacturers comply with stringent environmental regulations governing effluent discharge by achieving high removal efficiency for pollutants. Membrane filtration system ensures that effluent quality meets regulatory standards, thereby avoiding fines and penalties associated with non-compliance. Long-term sustainability. Membrane filtration offers a sustainable solution for textile effluent treatment, supporting the long-term viability of textile manufacturing operations. By improving water quality, reducing resource consumption and enhancing environmental stewardship, membrane filtration also contribute to the sustainability of the textile industry and its supply chain. Biological treatment for sustainable approach. We did discuss this a while ago, but we will look into it a little more, looking at the benefits of the biological treatment. So, biological treatment is a highly sustainable approach for treating textile effluent, offering numerous benefits. Biodegradation of organic compounds. Textile effluent often contain organic pollutants such as dyes, sizing agents and detergents, surfactants and so on. Biological treatment processes such as activated sludge, trickling filter and sequencing batch reactor utilize microorganisms to metabolize and degrade these organic compounds into simpler non-toxic substances, reducing the COD and improving effluent quality. So, if we use biodegradable components, then what happens that these organic pollutants can be easily biodegraded by the microorganisms and there is automatically reduction in COD value. Energy efficiency. Biological treatment processes typically require less energy compared to the physico-chemical treatment methods such as chemical oxidation or membrane filtration. The energy requirement mainly involves aeration for supply of oxygen into the water body for the microorganisms and mixing the wastewater, making biological treatment a more sustainable and cost effective option in terms of energy consumption. So, even in the biological system, the energy consumption is very regulated, it is not intensive. Low chemical usage. Biological treatment processes generally rely on natural microbial activity to degrade pollutants, reducing the need for chemical additives. This results in lower chemical consumption, minimized chemical handling and storage and reduced chemical sludge generation, contributing to a safer and more environmentally friendly treatment approach. Biomass production and resource recovery. Biological treatment system produce biomass, that is microbial sludge, as a byproduct which can be further processed and utilized for various purposes. For example, excess sludge can be dewatered and converted into biofertilizer or biogas through anaerobic digestion, contributing to resource recovery and circular economy principle. Versatility and adaptability. Biological treatment processes can be tailored to accommodate fluctuations in wastewater flow and composition, making them suitable for treating variable effluent streams from textile manufacturing operations by adjusting operating parameters such as hydraulic retention time, that is HRT, solid retention time SRT and nutrient levels. The biological treatment system can maintain optimal performance under changing conditions. So, there is a possibility that when we are using the biological treatment processes, we are able to adapt to the new composition of the influent and changing composition of the influent, because the influent is coming from various textile processes. Removal of nutrients. Textile effluent may contain high levels of nutrients such as nitrogen and phosphorus, which can cause eutrophication and other environmental problems if discharged untreated. Biological treatment processes, particularly those incorporating nitrification, denitrification and biological phosphorus removal, can effectively remove these nutrients, ensuring compliance with environmental regulations and protecting the receiving water bodies. Environmental compatibility. Biological treatment processes promote the natural breakdown of pollutants through biological pathways, resulting in environmentally compatible treatment products. Treated effluent from biological treatment system typically have lower toxicity and are less harmful to aquatic ecosystems, supporting environmental sustainability and biodiversity conservation. Long-term viability. By harnessing the power of nature to treat wastewater, biological treatment offers a sustainable and resilient solution for managing textile effluents. With proper operation and maintenance, biological treatment systems can provide reliable and effective treatment over the long term, supporting the sustainability goals of textile manufacturers and regulatory compliance requirements. So, if we look at this picture, this diagram, different modes of bioremediation are shown. From a colored effluent form of the textile effluent, it can take three different pathways. Pathway 1, where mixed culture remediation is done. Pathway B, where isolated organisms are only used, and pathway C, where enzymatic remediation is done. So, cleavage of the chromophoric group takes place with mixed culture remediation, transforming the modified dye molecules, whereas by isolated organism we get colorless textile effluent completely. By the pathway C, we get cofactors and co-substrates or mediators by the enzymatic remediation. So, different types of microbial activity happens in biological processes. Now, let us learn a little bit more in deep about the bioremediation. With mixed cultures, pathway A, there are more than one species involved in remediation process with separate motive with one species, cleavage of the chromophoric group, another biotransform the modified dye molecules, whereas others help in stabilizing the overall ecosystem. The biotransformed dye molecule will be more accessible to another organism that otherwise is not able to attack this dye. In this way, the decolorization could be achieved by mutually depending on the presence of several species on their synergistic action. However, isolated organisms are directly involved in dye transformation by pathway B. Alternatively, a third remediation process involves enzyme, which is pathway C. Their action may get enhanced depending on the presence of cofactors, co-substrates or mediators. Now, closed loop system for sustainable approach of textile is very much recommended. Why? Because we are cutting down the water capacity or usage of fresh water by recycling and reusing the same water which was used in the textile effluent. Water conservation. Implementing a closed loop is highly sustainable approach for managing textile effluent, offering numerous benefits: water conservation, wastewater minimization. Now, when we say water conservation, in a closed loop system, water used in textile processing is continuously recycled within the production facility, minimizing the need for fresh water intake and reducing water. Wastewater minimization, that means by recycling water within the closed loop system, the volume of the water generated by the textile effluent or textile production is automatically reduced, and therefore, this minimizes the discharge of effluent into the environment, mitigation of the environmental impact on the ecosystem, and reducing the burden of wastewater treatment facility. Pollution prevention is automatically there because everything is within the system. It is a closed loop system, effectively controls the pollutants within the production facility. Energy efficiency. Closed loop system typically require less energy compared to conventional water treatment and supply system. By recycling and reusing processes water on site, energy intensive processes such as pumping, heating and treating water are automatically minimized. We are using the same water. So, it is only the water processing cost that is occurring. Resource recovery. Closed loop system facilitate the recovery and reuse of valuable resources from the textile effluent. For example, nutrients, dyes and other chemicals present in the wastewater can be recovered and reused. Cost saving. Definitely in closed loop system, when we are using the same water again and again, by reducing the water and energy consumption, automatically there is a cost saving, and time and again we have been talking about it. Improve product quality. Closed loop system contribute to the production of high quality textiles by maintaining consistent process condition and minimizing variation in water quality. So, there is always one type of water that is being used. There is no change because that is where minimizing the variation in water quality takes place. This results in more reliable and predictable manufacturing processes. Enhance corporate image. We have understood that the production house will be surely benefited if they adapt environmental sustainability, responsible water management, enhancing the corporate image and reputation. Overall, closed loop system offer a holistic and sustainable approach to managing textile effluent, addressing water conservation, pollution prevention, resource recovery and cost efficiency. So, to sum up, in conclusion, adopting sustainable and green chemistry approach for treatment of textile effluent offers multifaceted benefits that contribute to both environmental conservation and economic viability. Environmental protection, resource conservation, health and safety, regulatory compliance, consumer demand, innovation and collaboration, and long-term viability. Embracing sustainable and green chemistry practices ensures the long-term viability of textile manufacturing by reducing environmental risk, enhancing operational efficiency and future proofing against evolving regulatory and market dynamics. Finally, the adoption of sustainable and green chemistry principles for treating textile effluent is not only a responsible choice for mitigating environmental impact, but also a strategic imperative for ensuring the resilience and prosperity of the textile industry in a rapid changing global landscape. So, with this we have come to an end of this lecture. Thank you.